Hey, how's it going? Here is our term project for database management, spring 2024. Um, Throughout this video, I'm going to be going through describing things using the evaluation form as was suggested in the deliverables file in the LC. So here's our home page. What we're doing with this application is, and to answer the first question here, what's new and interesting, is that we're doing a bit of an analysis on a couple of the most commonly used emotion analysis and sentiment analysis APIs. This is basically used for processing text. Sentiment kind of says, is this body of text positive or negative? It does that by identifying features, as in these keywords, and then summarizing that into a overall positive or negative for the entire past text. Emotion analysis, it does a similar thing, but it detects of 6 values: joy, surprise, sadness, disgust, anger, and fear. Detects those values, normalizes them, decides which values pass the threshold for normalization, and if one does, then it's going to say there's enough joy present in this text to say that joy was a present emotion. Here is our diagram. I'll show in a second how I got this data, because it's all organic. It's all real world data that was pulled directly from Twitter. But basically, we've got our tweets, the accounts that posted them, a one-to-many from accounts to tweets, and then the tweets have unique IDs. So it's a one-to-one on sentiments, because we have a positive or negative score for each tweet. But then when it comes to these keywords, you can already see it's going to be one-to-many for a tweet. So that's why we have this one-to-many on keywords. And then the same thing with emotions, because that's also putting out another array that's a one-to-many. And then for the accounts, obviously we're going to have a one-to-many because each account posts a lot of tweets. So how do we get this data? We want to find out, how quality is it? How do we get it? How complicated, the technical depth, sophistication, etc. Let's take a look. So, as you probably know, Twitter recently paywalled its developer APIs. This isn't really a popular move that they did, but Elon Musk's a businessman, so he's going to do something like that. Well, with that, you're going to have developers doing basically what I'm doing here, and to bypass having to pay for an API, you have a real account, and your real account is accessing Twitter's API somehow. So when you're in the browser, Twitter is assigning you a bunch of cookies and headers that basically authenticate you as being a real user, as being able to be provided tweet or Twitter profile and tweet information from their GraphQL API. So I'm utilizing that process. I opened the browser in a programming application a sniffing application called Burp Suite. I pulled all these headers, pulled the cookie, and then automated requests. So with this process, you can get about 800 tweets. They look like this. Nope, they look like this when they're raw data. It's a ton of information. It would be pretty freaking difficult to put all this, and honestly useless to put all this information in the MySQL database. So then I wrote this cleaner file. It's going to clean this down. So now for each of these accounts, we've got their account information, then we've got a list of their tweets, their last 800-ish. So for this one, we've got 844. We're going to compile that into one major file. This specifically is what's going to be populated into the MySQL database for accounts and tweets. So then we're doing that. We're doing that here. I've already shown you the diagrams. There's more specific ERR diagrams in our paper, but as for now, you get the idea of where we're going. Primary key being name for the accounts, references foreign key and tweets. Primary key of tweet is ID string. Both of those primary keys are referenced as foreign keys in all of these other databases. Really simply, here I can show you where we grab it. Analyze. We got emotions. Very simply, just iterated through that tweet list, made API requests. We had to do this sequentially because doing it in parallel, which I tried, got us rate limited, even though they claim not to be rate limited. It was just way too overwhelming for their back end, at least for the free subscriber trial. So anyway, I uploaded all that and then got the emotions.json and then the sentiments.json. And then all of this was added to the MySQL database to be displayed on our website. So for the website, we did React with, as I've mentioned several times, the MySQL backend. Just because of the nature of it, we haven't implemented any like skeleton DOM or virtualization of the list, so it takes a while to load. So I've already opened them up and loaded them here. So for Fox News, CBS News, and CNN, we have the following data. They're all slightly negative when it comes to the average sentiment. And then the emotions, as I've said, there's only 6 to choose from, which kind of shows the lack of complexity of the emotion analysis API, despite it being such a widely used AI, text analysis API. But as you're going to expect of a news outlet, any news outlet, fear is going to be the top emotion elicited. Closely behind for these two, CBS and CNN, it's sadness. Interestingly, they actually have the exact same top 6 rankings, but then you got Fox News, which is a little bit different, but not too far off. Something that we wanted to show with this, let me actually check our time right now. Okay, we're at 6 minutes, perfect. Something we wanted to show with this whole project, being that it's a critique on current AI APIs that are available for developers for text analysis, is that the sentiment analysis really isn't that good. You know, you see the top 4 here: have, say, new, not, have, say, will, former, new, live, follow, case, not, when. You know, the top 10 most frequent sentiment keywords, which, as I mentioned before, is how the AI, it extracts those features, being those sentiment keywords, and then decides, based on those extracted features, how the overall text is, as far as positive, negative, or neutral. These features aren't really all explicitly positive or negative. You know, have is extremely neutral. And it gives it a little bit more weight than it should. It's about, here we can see it, it's about 16% negative. That doesn't make any sense. It should be like complete zeros on neutral. So the normalization of that is a little bit weird. But that's, you know, being that it's a critique on those APIs, we don't really want to change that for the sake of displaying it. More so we want to critique how those APIs are, you know, sharing data. What's really interesting is when we come to this Fox News one, this is what's really upsetting, in my opinion, as of the current relationship that we have with our, you know, sentiment analysis, and saying that it's so fantastic, but really, you gotta understand that it's not when it comes to small text like this. You know, only identified graduation as a sentimental keyword, and it has a very high positive sentimental value, but it didn't really look at the whole context here. It labeled this tweet extremely positive. Additionally, the emotion it gave it was joy because of the same reasoning here. But, you know, Democrat governor swarmed by anti-Israel agitators while celebrating daughter's college graduation. There's nothing positive about this. I mean, yes, if you look explicitly on the graduation, sure, that's fantastic. But being swarmed by agitators during a positive event, that is horrible. That's even more negative than just being swarmed by the agitators. So, you know, with that, we see a lot of issue here with our sentiment analysis. And it shows that there's a lot of room for growth, you know? Anyway, with our actual user interface, we're displaying these colored keywords based on what the AI identified as contributing to the overall sentiment and the strength of that color. So if it's really bright, then it's going to have more strength. So top is supposed to be 54% positive according to the API, whereas like up is only 14% positive. So you can kind of see that the closer it is to black, it's not as impactful, but the closer it is to like a very bright red, you know, we have 69%, or a very bright green where we have 54%, or even enjoy, which is 99% positive, obviously. You know, we're going to show that based on colors. Now, this is a bit of an outlier, 99%. We don't want it to be that bright for user experience, but we want it to be consistent. And so what it is right now is consistent. So for each of our tweets, we have the overall, that's interesting. We ended up with an ad here. Anyway, that's just the nature of the API. or the Twitter API. But what we end up here is for each tweet we have the sentiment, the overall sentiment of the tweet, and then we have a list of the emotions present in the tweet. So I hope you found this pretty interesting. Let me make sure I've covered all the points here. The database design stuff, that's going to be in our paper. You can look there. Dataset quality. I've submitted that separately, but this is all real information. I mean, if you search this tweet up, you're going to find it on Fox News' Twitter. So I would say that is extremely high quality. And then the extraction method, you save a good bit of money doing it the way I did, and I feel like it's a fairly sophisticated and technical method of doing so I think that has merit. Front-end quality, I think it looks great. I personally think it does look really great, at least for what it's needed. We've got some colors, we've got variation in the text to display emphasis on certain things. Running demo completeness, as far as the smoothness, I mean, we've got everything that we need to display. There's only so, advanced that you're going to get in a project like this. Technical depth, we've kind of already been over that. Oh, we can actually look at the queries real quick before we wrap it up, because we're at 11 minutes. It's perfect. So for our queries, just keeping in mind what we have here, we've got 3 profiles. We need a query for that. And then we've got the average sentiment per news source. We want to query for that. The emotions by frequency, we want to query for that. Sentiment keywords by frequency, same thing. And then tweets, we're getting a lot of information here. So this is going to be our more complicated query. We're going to need to, pull the sentiment keywords associated with that tweet, pull the overall sentiment associated with that tweet, and then pull the list of emotions. So for the keywords and the emotions, that would give us several rows. What we're going to do is we're going to concatenate all that so that our emotions is a comma-separated list for the row, and then the keywords, we also have a comma-separated list, which is like word : score, just so we can all be like, we don't want our database returning 10 rows for this one tweet when we have 800 of these to go through. So that's worth keeping in mind here when we look at our database querying. So going to the top, you of course know it's just going to be select star from accounts. We're just going to give all the accounts on the home page. This is the query I just mentioned. We're going to select the tweet ID, posted by, created at, full text, and that's like for all of the tweets, or for all the tuples in the table. And we're also going to select concatenation of sentiment type, score, and ratio for each of our sentiments. And then, or for our sentiment, and then we're also going to have the group concatenation of the emotions, which we're just returning the emotions separated by a comma, so then you're going to have like the comma separated list of the emotions. And then same thing for the group concatenation of sentiment keywords, except we want the word : score before the separator, so then that's what that's giving. Now we want our sorted list of emotions. That's what this does. It ranks our emotions, and it orders it by quantity descending. Same thing with our sentiment keywords. We're just counting it, ordering it descending. We're only wanting to show like 20 here because otherwise you're going to have a couple hundred keywords where they just have like one frequency, or a frequency of 1. We don't want to show all of that extraneous data, those outliers. So we trim it at 20, which gives a fairly representative amount. And then our average sentiment score for the user. All of this source code is going to be submitted, so you can feel free to look through all of it. I've removed, as I mentioned before, things like the API keys, so if you wanted to implement this yourself, you'd have to do that, but it's neither here nor there. All right, index.js, it's just an express application. So when you get accounts, it's returning those accounts queried. Tweets an account, or tweets by account, it returns that query results, and otherwise just sends the overall React application. So here you go. I hope you enjoyed, and I hope you got a little bit of kind of where we're coming from with this text analysis, what we're thinking about it, where it's at right now and where we think it can go. because this could be really good and a really effective type of website, and it's at least a really good proof of concept of the implementation, but the APIs just aren't where they need to be yet, and I think that's worth noting. Anyway, thank you for watching, and I hope you have a great one.